In this lesson, we will learn about rational numbers. Rational numbers are denoted with the letter capital Q. So what are rational numbers? Rational numbers are numbers that can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. So what we are saying is any number that can be expressed in the form of a simple fraction where the numerator and denominator are integers and the denominator is not 0. So let's take an example. Let's consider this pizza. If you cut the pizza into 4 equal parts, and if I asked you to represent the slice A with respect to the whole pizza, you would say that A is 1 by 4 times P. So what you are saying is A is 1 out of the 4 equal parts of this pizza. So this number 1 by 4 is in the form of P by Q, where P and Q are integers and Q is not 0, and this is a rational number, and we call this a P by Q notation. The same thing can be expressed in the decimal notation as 0.25 times P. If you divide 1 by 4, you will have 0.25 as your quotient, so we represent it as 0.25 times P. As you see, the letter Q also comes from the word quotient, because rational numbers are nothing but quotients if you consider the decimal notation. So let's now see how to represent rational numbers on a number line. Previously we have seen how to represent integers on a number line. Now let's look at how we represent rational numbers. In order to represent 1 by 4, what we do is we divide the space between 0 and 1 into 4 equal parts. There's first part, your second part, your third part, and your fourth part. So you have divided this space into 4 equal parts. So the first part is called 1 by 4, second part is 2 by 4, third part is 3 by 4, and the last one is 4 by 4, which is nothing but 1. So in order to represent 1 by 4 on a number line, you would do this, and you can say 1 by 4 is right here. Now let us look at these integers for a second. If you observe the integers minus 5, minus 4, or 0 and 1 and 2, all these are not in the P by Q notation. But can we express them in the P by Q notation? Think about it. We can. Consider any integer, whether it's minus 5, 0 or 3. You can express it in P by Q notation by simply putting Q equal to 1. So these numbers now are in the form of P by Q notation where Q is 1. So all integers are rational numbers because they can be expressed in a P by Q notation where Q is 1. But are all rational numbers integers? No. As you see, 1 by 4 is 0.25. 0.25 is not an integer. So what we learned here is all integers are rational numbers, but all rational numbers are not integers. So in a set notation, what we are saying here is integers are a subset of rational numbers because integers are contained in rational numbers. But in the previous lesson we learned natural numbers are subset of whole numbers, subset of integers, and now we learned integers are subset of rational numbers. So we can say n subset w subset z subset q, which means all natural numbers, whole numbers and integers are contained in rational numbers. In other words, natural numbers, whole numbers and integers are all rational numbers. We have seen that rational numbers can be expressed in the form of decimals, like 1 by 4 is nothing but 0.25. In this lesson we will focus on this decimal notation of rational numbers and discuss the different types of decimals. So if you observe here 0.25, it terminates after certain number of digits. So the number of digits after the decimal point are 2. So that's a fixed number, which means the numbers are terminating. So and if you observe the digits, they are not repeating. So 2 and 5 are two distinct numbers. So these numbers are not repeating. So these are called non-repeating terminating decimals. But if you observe here 111 by 1000, it's nothing but 0.111. And as you see, these numbers are also terminating after certain number of digits. And the numbers are repeating here. So the 1 is actually repeated. So these are repeating and terminating decimals because they terminate after 3 digits. Now let's look at another example. So 1 by 3 is 0.33333 so on. These are repeating decimals and also not terminating, because there is no termination point for this fraction, and you represent them as 0.3 with a bar on the top of the number. So here we say it is as 0.3 bar. So it means 3 is repeating. Whereas 9 by 11 is 0.81, 81, 81, so on. And again, you see repeating decimals and non-terminating decimals. So these are called repeating and non-terminating decimals. And here the bar is shown on the top of the two digits that are repeating. So now let's look at this table. Decimals can be classified into 4 different types: repeating terminating, repeating non-terminating, non-repeating terminating, and non-repeating non-terminating. In the repeating terminating example, we have already seen 0.111. So this 0.111 can be expressed as 111 by 1000. So this is in the form of P by Q. So these are rational numbers. Similarly, in the repeating non-terminating case, we have seen 0.3 bar and 0.81 bar. And again, all these have a P by Q notation, like 1 by 3 and 9 by 11. So 1 by 3 and 9 by 11. So these are also rational numbers. Whereas in the case of non-repeating terminating, we have seen numbers like 0.25. Again, these are rational numbers because they have a P by Q notation 1 by 4. Whereas there is another case of numbers non-repeating and non-terminating. For example, 0.124687932, so and so on. So these are non-repeating and non-terminating, and we cannot represent these numbers in the form of P by Q. So these are not rational numbers. So what do we call these numbers? Think about it. We will talk about this in a next lesson.